The next thing we're going to look at is what are actually the types of long-term memory, because there are like different types that we look at. The first is explicit. So that's, for example, like facts, names, images, events. These are like declarative memories. They require conscious retrieval and they're the responsibility of the hippocampus. So how I remember that is I think like explicit, things you need to explicitly think about. And they're like declarative memories. So things you need to declare, like again, facts, names, numbers, and there's two subtypes of our explicit kind of long-term memory. There's like the episodic and semantic. So episodic, I think about it as like they're like the personal memories, like episodes from your life. So episodic memories are like memories of events and experiences from your life, and it can be past like or future. And then semantic are kind of like the more like facts, worldly knowledge, general knowledge, things you need to memorize and recall kind of thing. Whereas our implicit memory, think of it more like, internal, a little bit more automatic, is that memories of skills, emotions, preferences, and dispositions. And it's also called like procedural or like non-declarative memories. So procedural, like the memory of like how to do things. So for example, if you are very fluent in playing the guitar, it's going to be quite like effortless for you to play that because it's really easy to recall. It's very cemented in your brain. It's very like implicit. And yeah, they are processed in like the amygdala and possibly also the cerebellum. So again, with my guitar playing analogy, it requires little conscious awareness. It rarely fades with time, except for with disease, and the information is remembered unconsciously and effortlessly. Or for example, singing along to music. It's something we seem to do so automatically. And again, linking in with that idea of like, it's like a procedural memory, which is memory for how to perform certain tasks, skills, actions, or even like conditioned responses. So for example, again, riding your bike, brushing your teeth, these memories are very resistant to forgetting. They're very easy to recall. And with these implicit memories, you often don't have to actually think about them. Like even with, when you're riding your bike, you probably don't consciously think, okay, so how do I ride my bike again? It just kind of very naturally comes back to you. Our next kind of memory model is the levels of processing model of memory. So this model suggests that memory does not comprise any specific number of separate memory stores. Instead, it kind of sees memory as like a continuous dimension in which memories are encoded related to the ease with which they can be retrieved. So the deeper you process the information and like the more you encode it and the more you connect it with prior knowledge, like the greater chance that you'll be able to retrieve it. So it's all about like the level of processing, which again is like linked to like the number of associations between new and prior knowledge, because the more links you make, the deeper we encode it and the easier it is to retrieve, which is very important when it comes to studying, because there's something just like is a fleeting thought through your mind and you don't think about it again. That's not a very deep level of processing. You're not paying a lot of attention, you're not doing a lot of thinking. So you're probably not really going to be able to recall that or retrieve it because you haven't like encoded it in your brain. Whereas, however, if like you're trying to consciously learn something and you're making lots of connections, there's a much greater chance that you're going to be able to retrieve it. So with the levels of processing, again, we can have like those more shallow levels of processing, and we can also have like deeper processing. So the more shallow levels of processing, the first one is like structural processing. So that's when you kind of like remember the physical qualities or features of the words. So for example, is it a capital letter? Is it a lowercase letter? This isn't a very meaningful way to remember stuff, so it's a fairly shallow level of processing. When you have phonemic processing, like that's like when you're remembering like the sounds of the words, which again, not very deep because you're only remembering the sound. You're not giving it meaning. It's always going to be deeper if you give meaning to it, which brings us to our deep level of processing, which is semantic processing. And that's when you kind of like encode or store away memories by like kind of storing it according to meaning. So that's why like kind of organizing things in a mind map is like so helpful, because you're actually creating semantic connections in your brain that's like making connections, and because you're encoding it with meaning, it makes so much more sense, and it's so much more likely that you're going to be able to actually recall that information. And there are different ways that we can kind of like, I guess, make the most of each of these. So for example, with like, if you're trying to keep something in your mind, a really shallow way to do that is called maintenance rehearsal. So that's just like repeat and repeat and repeat. So if, for example, like I'm trying to remember a shopping list, I'm actually thinking, okay, eggs and bread, eggs and bread, eggs and bread. All I'm doing, that's maintenance rehearsal. I'm just repeating it again and again to keep it in my mind. That's not like a very meaningful way to do it. Whereas if you want to actually deeply process something and encode it in your brain, you're more likely to want to do elaborative rehearsal, which is where you actually give meaning to it and try and intentionally engage in that semantic, deep and meaningful processing. So the underlying message here is that memory grows stronger the more you elaborate on it and the more you link it to things we know and care about. So another model of memory, the working model of memory. So this kind of sees like, this kind of likens short-term memory to working memory. So you can kind of think of them as a little bit similar in this model. So working memory. What is working memory? So, well, first of all, the working model of memory kind of sees memory as made up of these 4 separate but interdependent parts. And so the main one, the kind of like how we define working memory in this model is it's like the store for any mental work that's occurring at any given time. That includes like retrieving information, problem solving, thinking, comprehending sounds, visions. It draws on information from sensory and long-term memory. So working memory is pretty much the information that we're consciously working on. So I kind of think of working memory as like, if you've seen the movie Inside Out, I think of it as like the headquarters. It's what's actively consciously going on. It's what's happening in your brain. So these 4 elements, these are like the 4 separate but interdependent aspects of working memory. So this is the working model of memory. And so these are like kind of like the 4 elements that we would consider to be part of working memory. The first one is the phonological loop. Think phone, sounds, hearing. The phonological loop is our auditory working memory. It's the storage of what we hear, and it's what helps us to understand sentences. And then we also have a second one is the visuospatial sketchpad, which is the storage for visual short-term memory. It's what we see. It's also what helps us to like visualize if we move things and change things. It's our visual working memory, what we're kind of like visualizing in our mind. Third one is the central executive, and that kind of puts together like the sound and the visual memory, and it also controls our attention, which is what enables us to mentally manipulate things. So the central executive, I see it like the control center, kind of like the boss, kind of like the control panel up the front of the brain in the movie Inside Out. It has like 3 main functions, which are inhibition, which is screening out irrelevant information. So I'm going to choose not to pay attention to that. Switching, which is when you choose to like change your focus to something else. And then also updating, so modifying items brought in from long-term memory before returning them to long-term memory through the episodic buffer. So I kind of think about that as like the memory tubes in Inside Out. So I kind of, I think about it like the little memory ball comes in from the tube. If they have to like modify the memory or like make changes to it, or if they like add to the memory, and then they can send it back to the memory tubes. And then we have the episodic buffer, which I kind of think about like a conveyor belt, like the memory tubes in the movie. So it's how we like retrieve information from long-term memory. And then by doing that, you can like make associations with this memory from long-term memory, and then you can add information to it in working memory, like in the control center in Inside Out, and then you can like select and encode information and then send it back to long-term memory. So that's our working model of memory, all about like the conscious what's going in my brain right now at this moment. Memory, the amygdala and hippocampus are quite involved in that. I definitely encourage you to do some extra research on that. A few brief things like the amygdala, it teaches you to detect danger and become afraid. It enables acquisition and use of classically conditioned memories. There's high levels of noradrenaline in the amygdala, which lead to stronger memories. It's activated by strong emotions at the time of encoding, and the emotional reaction stimulates adrenaline release, which is associated with like the fight, flight, freeze response. So when we think about the role of the amygdala in memories, I definitely associate that with like our emotional association with memories. So when you have a memory and it's like very associated with an emotion, that definitely makes me think of like the amygdala's role in memory. The hippocampus is crucial in consolidation of new declarative memories, which we talked about just before, as well as the transfer of memories to the cerebral cortex for storage. The hippocampus has a really, really big role in memory. You definitely need to do some research into that as well. Like it also has a role in spatial memories, and it has place cells which help us to create like a mental map. It also might help us like retrieve memories, not as important for procedural memories. And it does work with the amygdala so that declarative aspects of emotional events are remembered. So to kind of like summarize the main difference, amygdala is kind of like the emotional aspect of memories, and the hippocampus is kind of like crucial in the consolidation of new declarative memory. So remember, declarative memories like the facts, the events, the things you need to consciously recall. So hippocampus has a lot to do with like transfer of memories and the storage of the memories. The cerebellum is another really cool one in memory, which is like that little kind of like mini brain at the base of the brain near the brainstem. And the cerebellum encodes and stores like kind of like conditioned reflexes, like automatic movement is kind of how I think about it. Like it encodes and temporarily stores like procedural memories. So again, we're thinking hippocampus, declarative memories. Cerebellum is where we're kind of getting more into those procedural memories. It can also kind of like read the mental map created by the hippocampus, and it also has a major role in like coordination and motor learning. So how I kind of think of the cerebellum is it's about like remembering how to perform a motor skill. It's like a procedural memory store, and each time you practice that new skill, it'll add to your procedural knowledge of the task. And that's like why new things are harder as well, because you're putting so much conscious effort into like learning this new skill. But as you practice, it gets more smoother and automatic, because the cerebellum has a lot to do with like voluntary movement as well, like that balance and coordination. But as far as memory goes, it's more about like that coordination and remembering how to do a movement smoothly. So for example, I've been learning to play the ukulele recently. I've been really enjoying that. And when I first started, it was like so hard because I'd never played a stringed instrument before. I didn't know where or how to put my fingers, and it was just so challenging for me. But as I practiced that and consolidated my procedural memory of that task, it got so much easier with time. So much easier with time. And then it just, started to come back to me more naturally because of that procedural memory of that task, which again becomes more smoother and automatic with time. So the cerebral cortex is also involved in memory. A lot of people see it as like the storage site of declarative memories in long-term memory. So episodic memories are kind of like stored throughout, but especially in like the right prefrontal cortex. And again, this is all quite specific information, so don't be overwhelmed if you can't remember all of this all at once. Semantic memories are stored throughout the brain, but especially in like the temporal and the frontal lobes. And then pieces of memory are usually stored in an area or the lobe where the information was initially processed in. And again, it's very important in reconstruction, especially for declarative memory. But again, my main takeaway for you guys about this slide is all mostly just like about making sure that you're really aware of the idea. The memory is incredibly complicated. Like there are so many different like elements of like the brain that like play a role in it. And yeah, it is very complicated, and all of the different elements of the brain work together to make that happen. There are also different types of retrieval. The three main types are recall, recognition, and relearning. So in recall is when we're retrieving information, but all you need to do is identify the correct option without being given a list of possible answers. And then in recognition, that's when you need to only select the correct option from a list of alternatives. But relearning is where you've kind of forgot what you've learned and you actually need to relearn it all over again. But it is a lot quicker than learning the first time around. It's a much faster process. You make much less errors, and it's just generally an overall a much smoother process. So we have these three types of retrieval. Recall, where you need to bring the information back with a very minimal cueing. Recognition, so recall, I kind of think about it like our recall, I'd say, is kind of like our short answer questions on a test, I guess. Whereas recognition is our multiple choice. All you need to be able to do is select the correct response from a list of alternatives. Whereas relearning is when you got to learn it all over again. But again, it is much quicker and more efficient than learning something for the first time. And we are running a little bit low on time. We only have a few moments left. So to finish this up, I'm just going to quickly touch on the concept of forgetting long-term memories. So how do we actually forget? There are actually a few different theories on this, and it is quite interesting. The first kind of theory is the idea of ineffective coding, which is kind of known as encoding failure theory, which is kind of the idea that maybe the information was never actually encoded or stored properly in the first place. And we can kind of contrast that with ineffective retrieval, which is referred to as retrieval failure theory, which is quite given away in the name, where we actually are just failing to retrieve it. So that's the idea, that the memory is in there somewhere. It was encoded, it is in there somewhere in the back of our mind, but we're just failing to retrieve it. So that's where the name comes in really handy with that retrieval failure theory, is the idea that yes, the memory is there, but we're just struggling to retrieve it. And the idea of that is that there's poor retrieval cues. So cues are kind of things that prompt us to remember our memories. The kind of two main types that we look at are context-dependent cues, which are cues in the external environment, like a sound or a smell. And then we can also have state-dependent cues, which refer to the internal environment of the learner when the learning took place. And it includes psychological and the physiological state of the learner, such as their mood and everything. And another really key thing about that is if we're trying to learn information, if we're trying to recall information under similar conditions to which we originally learnt it, we're actually going to be much more likely to retrieve it. And again, that brings us back to the importance of encoding information properly, encoding it according to meaning and semantically, so that you can actually encode it and intentionally, if you really want to remember something, actually intentionally placing the right cues so that you can retrieve that memory. And there also are multiple ways that we can try and improve our memory and reduce the likelihood of forgetting, like mnemonics, the SQ4R method, which we have here, and a whole lot of other ways. But we actually have run out of time for those for today, so we won't quite get to those. But again, remember, the slides are available for you to download, so if you would like to go through this afterwards, you are more than welcome to.